Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help them uh, explore my channel, and maybe in the future you can also help them improve in their thinking skills and share whatever I uploaded in my YouTube channel, because this is for all. Now, if you like what I'm doing, and if my videos are important to your studies, also please don't forget to subscribe. Level 6. The 425 Newton force P is applied to the 1000 Newton crate, which is stationary before the force is applied. Determine the magnitude and direction of the friction force F exerted by the horizontal force by the horizontal surface on the crate. So here is the given figure. We have a 1000 Newton crate uh, pushed by the 420 Newton force horizontally, and we have coefficient of static friction 0.5, coefficient of kinetic friction 0.4. So for the solution, the free body diagram, we have the weight 1000 newtons, summation forces y, so the normal force on the floor will also be 1000 newton, and the friction force should be opposite to 425 newton. So if F max is 0.5 of normal, so 500 newtons, and since F max is 500 newtons, the applied force is 425 newtons. That means that the crate remains at rest, and therefore the friction force for this box to remain at rest will also be 425 newtons. So summation forces horizontal, 425 minus F equals 0. So F is 425 newtons, which is less than the maximum frictional resistance under the crate or the box, so that this will remain at rest. So therefore F is 425 because the box remains stationary and it is leftward. Level 7. The 700 Newton force is applied to the 100 kilogram block, which is stationary before the force is applied. Determine the magnitude and direction of the friction force, small f, exerted by the horizontal force by the horizontal surface on the block. Here is a given figure. First, let's solve for the normal force. So for the solution, we have the weight of the block, which is 100 times 9.81, then the normal force on the floor to be solved, then friction force is, let us say, to the left. Summation versus normal equals 0, so normal force sub F plus 100 plus 700 sine of 30 degrees equals 100 times 9.81. So solving for the normal force on the floor is equal to 631 newtons. Then summation forces horizontal equals 0. So by the way, the maximum frictional resistance is zero point 0.8 of normal force. 631 is 504.8 newtons. Then Fk max is zero point 0.6 of 631, so it is 378.6 newtons. Summation forces horizontal equals 0. 700 cosine of 30 minus F equals 0. So that means F is 606.2 newtons, which is greater than the maximum frictional resistance for which the block will remain at rest. Since the required friction force exceeds the maximum frictional resistance that the block offers for it to remain at rest, so that means this block will slide or move to the right. Because the block moves, when the block moves, the maximum frictional resistance is that of kinetic friction, and it is equal to 378.6 newtons by principle. Therefore, F is 378.6 newtons to the left. Level 8. The designer of a ski resort wishes to have a portion of a beginner's slope on which the skier speed will remain fairly constant. Tests indicate the average coefficients of friction between skis and snow to be mu sub s 0.10 and mu sub k 0.08. What should be the slope angle theta of the constant speed section? So by principle and by analysis, take note that we are required to determine the slope angle theta of the constant speed section. So that means that section where the skier will have constant speed. So therefore, this problem belongs to dynamics. So although tangent of theta is equal to mu sub k by experience or by principle, so we have to show that it is tangent theta is really 0.08. So let's have the free body diagram. The weight of the skier, then the normal reaction, and friction should be opposite to the component of the weight in the direction of in this direction, the hill. So we have F here. So NF, summation force is normal. So friction equals Fk max, that's the analysis, 0.08 of NF. Summation forces normal equals 0, so normal force sub F minus W cosine theta equals 0, so NF is equal to W cosine theta. Then summation forces horizontal equals 0, so 0.08 of NF, which is this friction max here in the dynamics range, minus W sine theta equals 0. Substitute the value of NF, which is W cosine theta, so 0.08 times W cosine theta equals W sine theta. Cancel out W. Tangent theta is 0.08 as expected. So theta is arctan of 0.08, and that is theta equals 4.574 degrees. Level 9, the coefficient of static friction and kinetic friction between the 100 kilogram block and the inclined plane are 0.3 and 0.2 respectively. Determine letter A, the friction force F acting on the block when P is applied with a magnitude of 200 newtons to the block at rest. The force P required to initiate motion up the incline from rest, and the friction force F acting on the block if P is 600 newtons. So we are given three conditions or three situations here. First, the friction force F acting on the block when P is applied with a magnitude of 200 newtons to the block that is at rest. So let's find out if the block remains at rest or it is in impending motion or it is in motion by dynamics. And to do that, let's have the solution. The normal force, the weight 100 times 9.81, the normal force is denoted by NF. And friction force, let's anticipate that it is, let us say, down to the left. So summation forces normal, we have superimposed the normal and the tangential axis. So normal force, summation force is normal equals 0. Normal force, this is also 15 degrees because the inclination of the plane is 15 degrees. So normal force plus P sine of 20 degrees equals 100 times 9.81 cosine of 15. Since the force, the magnitude of P is 200 newtons, substitute here. So NF plus 200 sine of 20 degrees equals 100 times 9.81 cosine of 15 degrees. Solving for NF, NF is equal to 895.81 newtons. The maximum frictional resistance is mu s times NF. So 0.3 times 895.81, and that is 268.74 newtons. Then Fk max is 0.2 of 895.81, and it is equal to 179.60 newtons. So we can now solve for F by summing up forces along the tangential axis equals 0. So 200 cosine of 20 degrees minus 100 times 9.1 sine of 15 degrees minus F equals 0. Solving for F, F is negative 65.96 newtons, so that means F should be in the opposite direction. And because F is in opposite direction and it is only 65.96 newtons, which is less than uh, F max, so the block remains at rest, and therefore the magnitude of the friction force is 65.96, and it should be directed up to the right with an angle 15 degrees to the horizontal. So F is 65.96 newtons up to the right, which is less than F max. So the block remains at rest and friction force is 65.96 newtons up to the right at 15 degrees to the horizontal. So that's it for the first part. For the second part, the force P required to initiate motion at the incline from rest. So it is clear in this statement that we have impending motion because we have to determine the force P to initiate motion, and friction maximum is mu sub s times normal. So B is F equals F max equals 0.3 of NF. So to solve for NF, summation forces normal equals 0, NF plus P sine 20 degrees equals 100 times 9.81 cosine of 15 degrees. So NF is 947.57 minus P sine of 20 degrees. Then summation forces tangential equals 0. Take note that F is F max 0.3 of normal. So P cosine 20 degrees minus 100 times 9.21 sine 15 degrees minus F or equals F, and F is equal to F max 0.3 of normal, and normal floor on the floor is 947.57 minus P sine of 20 degrees. So factor out P, then P times cosine 20 plus 0.3 sine of 20 degrees equals the combined value of 0.3 times 947.57 plus 100 times 9.21 sine of 15 degrees is 538.17. So from here we can solve for P, 538.17 over the quantity cosine 20 degrees plus 0.3 sine of 20 degrees, and that is P equals 516.3 newtons. Then for part C, the friction force F acting on the block if P is 600. So take note that when P is 516.3, we have impending motion up to the right, and F is F max. Therefore, when P is 600 newtons, we expect that this block will be in motion. So to verify that P is 600 newtons, NF is NF plus 600 sine of 20 degrees equals 100 times 9.1 cosine of 15. And solving for NF, NF is equal to 742.36 newtons. Then F max is 0.3 of, or summation forces tangential equals 0. 600 P cosine of 20 degrees or 600 cosine 20 degrees minus 100 times 9.1 sine of 15 degrees minus F equals 0. So solving for F, F is 309.91 newtons, and this value is greater than F max. Therefore, the block moves up to the incline, and since the block is in motion, the maximum frictional resistance is that of kinetic friction, and therefore F is equal to Fk max, and Fk max is 268.74. Our final answer is 268.7 newtons. So F max is coefficient of friction 0.3 times 742.36. This is not the value, this is the value because it is based on the actual normal force when P is 600. But this is still less than 309.91, so that means the block moves, and therefore the answer is Fk max. Fk max is 0.2 of 742.36, 148.47. So by principle, because the block is in motion, the maximum frictional resistance that can develop is equal to Fk max 148.47. So our final answer is F equals 148.5 newtons because the block slides up the plane. So 148.5 newtons. So that's it. Level 10, the magnitude of force P is slowly increased. Does the homogeneous box of mass M slip or tip first? State the value of P which would cause its occurrence. Neglect any effect of the size of the small feet. So we neglect the size of this small feet here. So for the solution, we have the weight which is mg, and we have n sub c here. Friction is F max because the condition is we have to compute for P in terms of mg if slipping occurs first, and we have to solve for P if tipping occurs first. So at their maximum value. So for tipping, there's no reaction at B of fit B, then only at C. So we have N sub C and F max. So N sub C plus P sine 30 equals mg. So N sub C is mg minus P sine of 30 degrees. Then summation forces horizontal P cosine 30 minus F max, which is coefficient of friction static 0.5 times N sub C, and N sub C is mg minus P sine 30 degrees. Therefore, P is zero point 0.5 of mg divided by quantity cosine 30 plus zero point 0.5 sine 30 degrees. And P would be 0.4480 to mg if slipping occurs first, because our equation is summation forces horizontal. Then if tipping occurs first, we sum up moment about C. We have horizontal component clockwise, vertical component clockwise also. The only counterclockwise is that of mg. So P cosine 30 times D plus P sine 30 degrees times 2D equals mg times D. So cancel out D, solve for P. P is equal to 0.5359 of mg if tipping occurs first. If slipping occurs first, we sum up moment about C. There's no reaction here. When the homogeneous box is about to slide or tip about C, there's no reaction here. So summation moment about C equals 0. P cosine 30 if tipping occurs first. So P cosine 30 degrees times D plus P sine 30 degrees times 2D equals mg times D. Cancel out D, so that's why this is the result. Since at 0.44802, when P is 0.44802 of mg, the uniform or homogeneous box is about to slip, and it will require greater value of P for the box to tip. Therefore, when P is 0.44802, lower than this, the uniform box is about to slide. So motion is initiated when this value of P is attained or reached. Therefore, our answer is slipping occurs first, box slips first, then the magnitude of P when the box slips is 0.4480 of mg to 4 significant figures, and the value of P when tipping occurs first is 0.5359 of mg. So that's it for this problem. I hope that you were able to follow and understand the explanations. Sorry for my voice. I have a lack of sleep, so I hope you can uh, bear with me. And thank you for watching.